My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Factors and factoring are topics that do not seem very useful when you first learn them. However, they become increasingly more important as you learn more mathematics. Additionally, there are many times in everyday life that we need to know which counting numbers divide evenly into a number. Let me start with a few definitions and explanations so everything is clear. First, any two counting numbers that multiply to a given number are called factors of that number. For example, 2 and 5 are factors of 10 because 2 times 5 equals 10. The factors of a number can be used with the area model of multiplication to create rectangles. Another rectangle with an area of 10 is one with a height of 1 and a length of 10. Because 1 times 10 equals 10, 1 and 10 are also factors of 10. There are several ways to factor a number, and some of the methods have different names. However, the purpose of every technique is the same. A simple way to find all the factors of a number is to make an organized list. Start with 1. Determine what value times 1 is your target number. Write the pair down. Ask yourself if 2 times a number equals your target number. If there is a number, write the pair down. If not, move on to 3. Continue increasing the first value until you reach a number you have already written down. Then stop. When we factor a number, we look for all the unique pairs of factors. While 5 times 2 and 10 times 1 are also equal to 10, they are the same pairs of listed factors, so they are not counted twice. Can you name the factors of 6? 6 has 4 factors, 1 and 6, and 2 and 3. What about 20? 20 has 6 factors, 1 and 20, 2 and 10, and 4 and 5. Finally, try 19. 19 only has 2 factors, 1 and 19. Numbers greater than 1 that only have factors of 1 and themselves, like 19, are called prime numbers. Prime numbers have many uses in cryptography and some technologies, but most people only need to understand the basics. Numbers greater than 1 that have more than 2 factors are called composite numbers. 6 and 20 from our previous examples are composite because 6 has 4 factors and 20 has 6. Is 9 prime or composite? 9 is composite because it has factors of 1 and 9 and 3. How about 5? 5 is prime because its factors are 1 and 5. In some situations, composite numbers are very useful, especially composite numbers with many factors. One trait of composite numbers is that they factor into prime numbers. When we factor a number down to a set of prime numbers, this is called the prime factorization. For example, 2 times 3 times 3 is the prime factorization for 18. Every counting number 2 and greater has a unique prime factorization. If you want to find the prime factorization of a number, you could make a list for the prime factors. I find that it is easy to miss factors this way, especially if a number has many prime factors. I use a binomial tree to help me find all the prime factors. I will walk through the process of finding the prime factorization for 18 using a binomial tree. I begin by systematically checking to see which prime numbers divide into our target number. With each number that needs factoring, I start with the smallest prime number, 2. First, I ask myself, is 2 times a number equal to 18? Since 2 times 9 is 18, I write these two factors below the 18. Since I have found factors of 18, I am done with it and move to the next level of the tree. On the second level of the tree, I start with the 2 on the left. As 2 is a prime number, I will circle it to signify that it is prime. My goal is to find the prime factors, and prime numbers cannot be factored. So, I'm done with it. I move to the next available number in the tree, the 9. Is 2 times a number equal to 9? No. Is 3 times a number equal to 9? Yes. 3 times 3 is 9. I write these two factors below the 9. Since I found factors of 9, I am done with it. I move to the next unused value in the tree, the 3. Is 2 times a number 3? No. Is 3 times a number equal to 3? Yes. In fact, 3 is a prime number. I circle it. The same is true with the other 3. It is prime as well, so I circled it. Notice that the numbers at the bottom of our tree are all circled. This lets us know that this process is complete. If any number is not circled, it needs to be factored. If all numbers in the tree are factored to primes, then the process of finding the prime factorization is complete. Now we can write down the answer. Remember that the name is a binomial tree. Each value can only have 2 numbers under it, a pair of factors of the number. If the number does not factor, it is prime and should be circled. Pause the video and try 20 and 100. 20 factors into 2 times 10. 2 is prime, so it is circled. 10 factors into 2 times 5. Both 2 and 5 are prime, so they are circled. The prime factorization is 2 times 2 times 5. 100 factors into 2 times 50. 2 is prime, so it is circled. 50 factors into 2 times 25. 2 is circled again. 25 factors into 5 times 5. 5 is prime, so both 5s are circled. The prime factorization for 100 is 2 times 2 times 5 times 5. There are other ways to create binomial factor trees. This is just my process. You can use any factors. I just use prime numbers since that is the goal of this process. Also, if you are not comfortable with multiplication, a multiplication table is helpful, as is a calculator. Finally, something called a sieve of Eratosthenes is helpful for finding and identifying prime numbers. The last central concept is common factors. 2 numbers that have the same factor are said to have common factors. For example, 10 and 25 have common factors of 1 and 5. Since 5 is the largest common factor, it is called the greatest common factor. Common factors allow us to simplify fractions, understand relationships between values, and even create rectangles with a common side length. Some like to list out all factors of both numbers to find the common factors. But prime factorization also helps with finding common factors. To use the prime factorization, identify the prime numbers that appear in both prime factorizations. The prime factorization shows 1, 2, and 2 3s are shared. Any combination of these prime factors will produce a common factor. Multiplying all the shared prime factors together gives us the greatest common factor, the largest number that divides evenly into both numbers. In my mathematical world, I have one little problem. I am planting some vegetables in my garden, and I like to organize them in rows. Finding the common factor between the number of different types of plants tells me how many rows can be made and the number of plants in each row. For example, I have 30 red potato plants and 27 white potato plants. I could plant one really long row with all 57 plants, but my neighbors might hate it. Since it's not a great use of space either, I should find a number greater than 1 that is a common factor of both 30 and 27. I will use a binomial tree. Starting with my 30 red potato plants, 2 times 15 is 30. 2 is prime, so it is circled. 15 is 3 times 5. 3 is prime, so it is circled. 5 is also prime. It is circled as well. Since all values have been factored into prime numbers, the prime factorization for 30 is 2 times 3 times 5. 27 white potato plants are not divisible by 2. However, 3 times 9 is 27. 3 is prime, so I circled it. 9 is 3 times 3. Again, 3 is prime, so I circle both. This tree is also complete, so the prime factorization is 3 times 3 times 3. Notice that both the 30 and the 27 share one 3. Therefore, 3 is the only factor greater than 1 and is the greatest common factor. This means I can create 3 rows. Each row will have 10 white potato plants and 9 red. I have 72 jalapeno pepper plants and 32 sweet pepper plants. Draw a picture to show the greatest number of rows that I can make from the 2 types of peppers. I am planning to plant 165 carrot and 45 onion plants. Draw a picture to show the greatest number of rows that can be made from the carrots and onions. I plan to plant 88 beets and 144 broccoli plants. How many rows can be made with the 2 plants? Finally, I love tomatoes. I am planting 3 different types. I plan to plant 36 giant slicing tomato plants, 108 Roma tomato plants for sauce, and 9 cherry tomatoes. What is the greatest number of rows, and how many plants of each type will be in each row? Take a look, and you will see a mathematical world around you filled with situations where you need to find a number that divides evenly into another number. 2 numbers are called factors of their product. Common factors are useful when working with fractions and algebra, but the idea of taking a large thing and breaking it into smaller pieces is something you will find all around you.